Freezing rain is the name given to rain maintained at temperatures below freezing by the ambient air mass that causes freezing on contact with surfaces. Unlike a mixture of rain and snow or ice pellets, freezing rain is made entirely of liquid droplets. The raindrops become supercooled while passing through a sub-freezing layer of air hundreds of meters above the ground, and then freeze upon impact with any surface they encounter, including the ground, trees, electrical wires, aircraft, and automobiles. The resulting ice, called glaze ice, can accumulate to a thickness of several centimeters and cover all exposed surfaces. The metacode for freezing rain is FZRA. A storm that produces a significant thickness of glaze ice from freezing rain is often referred to as an ice storm. Although these storms are not particularly violent, freezing rain is notorious for causing travel problems on roadways, breaking tree limbs, and downing power lines from the weight of accumulating ice. Downed power lines cause power outages in affected areas, while accumulated ice can also pose significant overhead hazards. It is also known for being extremely dangerous to aircraft since the ice can effectively remold the shape of the airfoil and flight control surfaces. Freezing rain is often associated with the approach of a warm front, when subfreezing air is trapped in the lowest levels of the atmosphere while warm air advects in aloft. This happens, for instance, when a low-pressure system moves from the Mississippi River Valley toward the Appalachian Mountains and the St. Lawrence River Valley of North America during the cold season. With a strong high-pressure system sitting further east, this setup is known as cold air damming and is characterized by very cold and dry air at the surface within the region of high pressure. The warm air from the Gulf of Mexico is often the fuel for freezing precipitation. Freezing rain develops when falling snow encounters a layer of warm air aloft, typically around the 800 millibars before reaching the ground. However, if the subfreezing layer of air at the surface is very shallow, the raindrops falling through it will not have time to freeze and they will hit the ground as supercooled rain. When these supercooled drops make contact with the ground, power lines, tree branches, aircraft, or anything else below 0 degrees Celsius, a portion of the drops instantly freezes, forming a thin film of ice. Hence freezing rain. The specific physical process by which this occurs is called nucleation. Surface observations by manned or automatic stations are the only direct confirmation of freezing rain. One can never see directly freezing rain or snow on weather radars, Doppler or conventional. However, it is possible to estimate the area covered by freezing rain with radars indirectly. The intensity of the radar echoes is proportional to the form of the precipitation and its diameter. In fact, rain has much stronger reflective power than snow, but its diameter is much smaller. So the reflectivity of rain coming from melted snow is only slightly higher. However, in the layer where the snow is melting, the wet flakes still have a large diameter and are coated with water, so the returns to the radar is much stronger. The presence of this bright band indicates that there is a warm layer above ground where snow melts. This could be producing rain on the ground or the possibility of freezing rain if the temperature is below freezing. This artifact can be located, like on the image at left, with a cross-section through radar data. The height and slope of the bright band will give clues to the extent of the region where melting occurs. Then it is possible to associate this clue with surface observations and numerical models. Prediction to produce outputs such as the ones seen on television weather programs that divide radar echoes into rain, mixed and snow precipitations. Freezing rain often causes major power outages by forming glaze ice. When the freezing rain or drizzle is light and not prolonged, the ice formed is thin and usually causes only minor damage, but still as a rain droplet, it conforms to the shape of the ground or object such as a tree branch or car. This makes one thick layer of ice, often called glaze. Freezing rain and glaze ice on a large scale is called an ice storm. Effects on plants can be severe, as they cannot support the weight of the ice. Trees may snap as they are dormant and fragile during winter weather. Pine trees are also victims of ice storms as their needles will catch the ice, but not be able to support the weight. In February 1994, a severe ice storm caused over $1 billion in damage in the southern United States, primarily in Mississippi, Tennessee, Alabama, and western North Carolina, especially the Appalachians. One particularly severe ice storm struck eastern Canada and northern parts of New York and New England in the North American ice storm of 1998. Tree downed by a thick layer of